So here are the calculations for the Cannon lab. This is what you need to know, is that this Cannon is 7.56 plus or minus 0.1 kilograms is what I think. And I did that because I did that by putting the thing on a scale and putting all these little attachment weights on it. And you're only supposed to put 2, but I put 7 on there. So I'm pretty sure that it wasn't exactly right, but it seemed to be, you know, measuring fairly accurately. And then where did the tennis balls go? There they are. Okay, this tennis ball right here, I would guess that it's got a mass of, I'm really pretty good at just this sort of thing. I would guess that it has a mass of, if I just had to guess, I would say, I would just guess that it's 56.2 grams, just if I did a guess, right? So this tennis ball here is 0.0562, and I'm going to say plus or minus 0.005, because it could have been 5 grams, right? So this is kilograms, and that's because it had a lot of methanol in it. Yeah. Okay. Yeah. Somewhat less after it like burned for quite a while. Yeah, there it is. Yeah, I need new tennis balls, don't I? Okay. And then we've got data. We've got data. Do you have data?
I have data.
All right. And a pen. Look at this. All right. The first one, which we think was the hottest one, wasn't it? Except for the fire part of hot. Okay. So the first trial, just write this down. Here's our data. Is 3.62 meters, and the times were 9.33, 9.83, and 9.29 seconds. Right? And then the other trial is 3.5 meters. Right? And this is 9.21, 9.21. Look at that. 9.49. One of these things does. I'm just kidding. Okay. And this is, we think this is plus or minus 0.1. At least I'm going to guess that we probably could have been 0.1 off, maybe. I don't know. Certainly we didn't make a mistake bigger than that. Okay? Because Lauren and Jasmine and my IQs have got to add up to like 100. So, right? We're, you know, they're like looking at me like eyes of death. Okay. 9.21. Okay. So isn't it a reasonable thing to take this and average those? Shouldn't we average those?
Yeah.
There we go, yeah. Okay, so 9.33 plus 9.83 plus 9.29. Okay, divided by 3. I'm so clever. I'm going to say 9.48. And then plus or minus what? Well, it's this guy minus this guy, isn't it? So that's 0.5, isn't it? Isn't it? I don't know. I can't do it in my head. 0.83 minus 0.29 divided by 2. Plus or minus 0.27. Yeah? For this one, I just did the high minus the low, right? Divided by 2. It's a range divided by 2. It's a typical thing, right? Okay. So this is our time, right? And now the first thing we can do is we can find the velocity of the cart right after the collision or after the explosion, right? So that's going to be is 2 times 3.62 divided by 9.48. What is that? All right. That is 7637 meters per second. Is everybody doing this on like a sheet of paper they can turn in? Yeah, there we go. This is good. Don't not do this because it's like lab points and it'll be like this hole in your grade. Okay, so now we can set up our momentum situation. And I'm going to say that this cart going this way was negative and that this guy's positive. It doesn't really matter, right? So isn't it true that the momentum before it went boom was 0? Right? And then afterwards it was 7.56 going at negative 0.7637. If we make it go to the left, then we make it negative. I mean, it doesn't matter, right? Plus point, what is it? 0.0562, right? Times v. And now this thing can be solved for v, yeah? Can't it? It can. Times 7 point. 100, I'm getting roughly 103, 102.7. That's pretty good. Yeah? How many miles per hour is that? Yeah, let's figure that out just for fun. So times 2.237, that's 230 miles per hour. Which actually I'm more impressed. I'm actually more impressed that a tennis player can serve a tennis ball at 140. That impresses me more than like this cannon using explosives. Can make it go 230. But anyway, you know, there we have it, right? Okay, so so that's that one. And then don't we need the uncertainty? Because I know that your parents are going to go, no, it couldn't be going that fast, right? You know. So what we could do is we could say, well, it's at least going this fast, right? Right. Worst case scenario is at least going this fast. So let's figure out the uncertainty, because I know you guys want to do that for sure. Right. I'd be holding you back if you didn't do that. So I take the number, I do that, right? And then let's just throw everything in the pot here. All we have to do is set up all the fractional uncertainties on the other side. So what did we measure and use for this that had an uncertainty? Yeah, the mass of the cannon was this guy, right? So it's going to be 0.1 over 7.56. That's important, right? And then it's three more things. Tennis ball mass, yeah. So 0.005. I just said 5 grams. I just made that up. And I said that because I think it can gain or lose 5 grams just because it soaks up methanol. Maybe not that much, but certainly it's not bigger than that, right? I'm not going to gain or lose more than 5 grams. Last period, this number was 5.8 something. So, then what else did we measure? Time, there we go, yeah. Can we just do that? Plus 0.27 over 9.48. One more. Distance. You guys are like reading my mind. It's like reading my dog's mind. I really want chicken. I will stare at you. I like to eat what he has on his plate. I will stare at him. I will wag my tail soulfully. So do you remember how to do these things? How do you solve for this guy? Do you just take this whole thing in parentheses and multiply by, oops, we need to borrow some space from that one. How many people does that make them feel better if you do that? To me, that's like infinitely better than like it going partly into that other thing's space. Yeah. That's like, it's legit now or something. I don't know why that is. It's a deeply seated need. So now this is the hardest thing, of course, is to calculate the uncertainty of that thing, right? So remember, you just go this whole thing in parentheses times that, right? So I'm going to go times parenthesis. And I just do it all in one swell foop. Some people still laugh at that joke. It's my favorite. In fact, I'm not sure I can say that correctly now.
I said to my mom when she corrected me, I was like,
did she?
okay.
Do you guys get like 16 and a third or something? Right? Right? So you would say, here's what you'd say, is that the velocity is 103 plus or minus 16. I think would be a reasonable thing to say. Right? So it could have been as slow as 103 minus 16 is only 87 times 2.237. Could have been as slow as 194. Right? That's still pretty darn fast. I think it would hurt. Right? You know? Okay, so here's the story. Doug and the kids, years ago, some kids wanted Duggan to try this out and like hit some target other than the boxes. So he took one of these little Timberwolf guys, like this guy. That's what happened to this guy too, right? He took one of those guys and stuck it out in front. Yeah? Now, those things have these little beanbag feet so that they can stand. Are you picturing this? You know what I'm talking about, like little beanbags? They're just, all they are little plastic pellets. We know this because when he hit the little wolf, okay, it basically eviscerated the top half of the wolf. It was just like fluff and stuff all over the hall, okay? But it actually ripped, and this is the amazing thing,